All right, this lesson is 3.2. The lesson is called Adding Rational Numbers. And notice it says page 1 because that means there are 2 pages in the lesson. Okay, so this is on adding rational numbers, which means we're going to be adding numbers that are positive and negative, also numbers that are fractions and decimals. So this, first of all, we have to remember our addition rules. Same signs add and keep, different signs subtract. Keep the sign of the bigger number, then you'll be exact. This is why I gave you that song, so you can remember the addition rules. But now we have to remember how to add with decimals and how to add with fractions. Okay, so this is a bunch of things together at the same time. So here we go. We're going to start with adding with the same sign. And adding with the same sign, remember, we same signs, add and keep. That means we add the numbers together and keep the sign. Okay, so here's an example. Negative 2.3 plus negative 4.5. Both numbers are negative. Okay, we're adding decimals with the same sign. Both numbers are negative. So we're going to add them together and keep the sign. All right, so we're going to line up all the place values. Line up all place values. Here's what that means. We have one place value to the left of the decimal. We have one to the right. With both numbers, there's the decimal. We have one to the left. We have one to the right. So we're going to line up our decimals, basically. Then we're going to do 2.3 and 4.5, and they're both negative, right? So we're lining up all of the numbers, making sure the decimals are stacked right on top of each other. Okay, and then we're going to keep the decimal, again, line that the decimals need to stay stacked on top of each other. Okay, so add each place value together. Okay, and bring down the decimal in a line. Okay, so that's what we're going to do. 5 plus 3 is 8. 4 plus 2 is 6. And since they're the same sign, negative, we keep the sign. Same signs, add and keep. Okay, we have negative 2.3 plus negative 4.5. We line up all of our place values. So the tenths places are together, the decimals are together, and the ones places are together. Make sure they line up, add them together, keep our decimal in a line, and then keep the same sign. Same signs, add and keep. Okay? Adding decimals with the same sign. Now we're going to add fractions with the same sign. This is a review of how to add fractions. And I made a mistake. So cross off GCF. That should not say GCF. It should say LCM. You use least common multiple when you are finding common denominators. So when we have a fraction addition problem like 1/2 plus 3/4, first thing we have to do is get common denominators. Okay, you cannot add fractions if they have different denominators. So this one has a denominator of 2. This one has a denominator of 4. We cannot add those together. So the first thing we want to do is find common denominators using LCM. LCM stands for least common multiple. All right, well, the least common multiple for 2 and 4 is 4, because 2 times 2 is 4, and obviously 4 times 1 is 4. So 4 is a multiple of both 2 and 4. And if you're not sure what I mean by that, let me show you. Here's a multiplication chart, right? Multiples of 2, 2, 4, 6, 8, 10, 12. Those are all the multiples of 2. Multiples of 4, 4, 8, 12, 16. So 4 is a common multiple for 2 and 4. 4 is a multiple for 4, and 4 is a multiple for 2. That's what I mean by least common multiple. It's the lowest common multiple. So if you're not sure how a multiplication chart works, these numbers up here are called factors. These numbers down the side are called factors. These numbers in the middle are multiples, okay? So the multiples of 2, again, 2, 4, 6, 8, 10, those are all multiples of 2. Multiples of 4, 4, 8, 12, 16, and so on. So the least common multiple is 4 because there's 4 in that row, and for 2s, there's 4 right there. So 4 is our least common multiple for 2 and 4. So we're going to use that as our common denominator. So we're going to change this fraction to fourths. Okay, now this one already has fourths, so we don't have to change it. It's already has 4 as a denominator. But this one does not. So how do we get 4? We multiply 2 times 2, right? So if we multiply the bottom times 2 to get 4, we have to multiply the top times 2. 1 times 2 is 2. So we basically just converted 1/2 to a fraction that is equivalent. 2/4 is an equivalent fraction to 1/2. It just has a different, it's just a way to make them common denominators. So 1/2, 1 times 2 is 2, 2 times 2 is 4. If I gave you 2/4 of a candy bar, that would basically be half of it, okay? So what do we do now? We keep the denominator in our answer at 4, okay? So the answer is going to have a denominator of 4. Then we add the numerators together. So let's write all that down. Rewrite each fraction with common denominators, which we just did, 4. And we rewrote the fraction 1. We rewrote this fraction 1/2. We didn't have to rewrite the 3/4. We just kept it as 3/4 because it already had a denominator of 4. But we're rewriting 1/2 and changing it to 2/4 so it has the same denominator. So rewrite each fraction with common denominators and then add the numerator. 2 plus 3 is 5, okay? And then keep the denominator. So the answer is 5/4. 2/4 plus 3/4 is 5/4. The problem with the fraction 5/4 is we call that basically an improper fraction. See how 5 is bigger than 4? So we can now convert that to a mixed number. Let me remind you how to do that. This says 5 divided by 4. A fraction is always a division problem, always. This says 5 divided by 4. So how many times can 4 go into 5? Well, it can go in 1 time, but there's going to be 1 left over, right? 4 can fit into 5 1 time with 1 left over. So the 1 becomes the numerator in the mixed number, and then you keep the same denominator. So 5 divided by 4 is 1 and 1/4. So the answer to 1/2 plus 3/4 is 1 and 1/4. They were the same signs, positive and positive. So we just add them together and keep the same sign, so the answer is also positive, okay? So adding fractions with same sign. Find common denominators using the least common multiple. Rewrite each fraction with common denominators. And then add the numerators and keep the denominator. So we converted 1/2 to 2/4 so that we could add 2/4 plus 3/4. That gave us 2 plus 3, which is 5. 5/4 is our answer. 5/4 is an improper fraction, so we converted it to a mixed number. 5 divided by 4 is 1, because 4 can fit into 5 1 time with 1 left over. That leftover becomes the numerator in the fraction part of the mixed number. So 1/2 plus 3/4 is 1 and 1/4. Okay? Now we're going to move on to adding with different signs. So let's remember the rule for that. Adding with different signs. Different signs, we're going to subtract. Okay? Same signs, add and keep. Different signs, subtract. Keep the sign of the bigger number, and then you'll be exact. So how does that work with decimals and fractions? Let's start with decimals. We're going to do the same thing where we stack the numbers up on top of each other. But remember, we're going to subtract. So we're going to write the number with the greater absolute value first, meaning we're going to write the bigger number first. So 2.3, 4.5. Just ignore the signs for now. 4.5 is bigger. So we're going to write that first. 4.5. Probably shouldn't have written, I should write smaller. But all right, so then what we're going to do is we're going to subtract, right? So we're going to write the number with the smaller or lower absolute value next. That would be the 2.3, okay? They have different signs, so we are going to subtract. Keep all your places in order and bring the decimal straight down into the answer. So everything is lined up. 5 minus 3 is 2. 4 minus 2 is 2. And then we're going to keep the sign of the bigger number. Well, the bigger number is 4.5, and that's positive, so our answer is positive, okay, positive 2.2. So the answer is 2.2. Okay? Same signs, add and keep, different signs, subtract. Keep the sign of the bigger number, then you'll be exact, okay? That's with decimals. Now let's do it with fractions. And notice in our sample problem, we are going to start with a 1/5 plus negative 4.5. So we put a mixed number in there. So if we have a mixed number in there, the first thing we have to do is convert that mixed number to a fraction. Okay, if you're going to add fractions, you have to have two fractions. So we have whatever we have with the fraction. If it's a mixed number, we have to convert it to a fraction. Okay, so start by, we're going to convert the mixed number to a fraction. How are we going to do that? All right, we have 4.5 or negative 4.5. The way you convert a mixed number to a fraction is this. You take the denominator 2 and you multiply it times the whole number. 2 times 4 is 8. 2 times 4 is 8. Then you add the numerator. That's 1. So 2 times 4 is 8. Plus 1 is 9. And then you use that 9 as the numerator, and you keep the denominator. The denominator is 2, so we keep the denominator. So, and now it's negative, right? It was negative 4.5, so it's negative 9 over 2. 2 times 4 is 8, plus 1 is 9. And then we keep the same denominator. So that's step number 1. If you have a mixed number in your addition or subtraction problem, you have to convert it to a fraction by multiplying the denominator times the whole number, add the numerator, that gives you your new numerator. Denominator times whole number, 2 times 4 is 8. Add the numerator, 8 plus 1 is 9. That's your new numerator. And you keep the denominator. So now what's our problem? Next we have to find common denominators. So let's write the problem. So 1/5 plus, and I'm going to use a parentheses, negative 9/2. That's our new fraction because we converted the 4.5 to 9/2. Now we have to find common denominators. Okay, 5 and 2 are not common denominators. That's two different denominators. So we have to find, again, the LCM, lowest common multiple of 5 and 2. If you don't know that off the top of your head, look at your chart. I'll give you a chart, okay? So 2, we have 2, 4, 6, 8, 10, 12, and so on. 5, we have 5 and 10 right there. There it is, okay? So 5 has 10 and 2 has 10. In fact, 5 times 2 is 10, right? So we're going to use 10 as our common denominator. That should be on the inside, negative. All right, so 5, I'm going to use a pencil here. 5 times 2, can you see that, is 10. So I'm going to actually multiply the top times 2 as well. 5 times 2 is 10. 1 times 2 is 2. Now here, to get 2 to be 10, we multiply it times 5, right? 2 times 5 is 10. So we have to multiply the 9 times 5. So that's, this whole thing is negative 45. Now, sorry, this is kind of sloppy. This is 2/10 plus negative 45/10. So we're going to subtract the smaller numerator from the larger numerator. So the 45 has a greater absolute value than 2. So we're going to do 40, because remember, same signs add and keep, different signs subtract. So we have to subtract, even though it's an addition problem, we have different signs. We have negative here and positive here. So because they're different signs in an addition problem, we have to subtract. So 45 minus 2 is 43, okay? 43. So we're going to subtract the smaller numerator from the larger, and we're going to get 43. Then keep the denominator. So the denominator was 10, right? So that's the answer, but keep the sign of the bigger number. The bigger number, 45, is negative, so our answer is negative. Okay, now look at this though. 43 is bigger than 10. So we're going to convert this again back to a mixed number. This is a lot of steps. I'm going to go over them one more time after I finish. 43 divided by 10. If you're not sure how many times 10 can fit into 43, look at your multiplication chart and look at your 10s. 10, 20, 30, 40, 50. 50 is too big, so go back down to 40. 10 can go into 40 4 times, okay? 10 can go into 40 4 times. So 10 can go into 43 4 times with 3 left over. 40, 41, 42, 43. Okay, so 3 is going to be our new numerator, and we're always going to keep the same denominator. So the answer to this problem, 1/5 plus negative 4.5, and remember this is negative, right, is negative 4 3/10. That was a lot of steps. So what did we do? We started out with our problem 1/5 plus negative 4.5. We know we're going to have to subtract that because we have different signs. We have a positive 1/5 and a negative 4.5. We know that we're going to actually have to subtract, even though it's an addition problem. Same signs add and keep, different signs subtract. And keep the sign of the bigger number. 4.5 is definitely bigger than 1/5, right? Then you'll be exact. So first step, convert the mixed number to a fraction. So we did that here. Negative 4.5 converted to a fraction is negative 9/2. How did we do that again? We keep the denominator. If it's 2 in the mixed number, it's 2 in the fraction. To get the numerator, multiply 2 times 4 plus 1. 2 times 4 plus 1. Denominator times whole number plus numerator. 2 times 4 is 8 plus 1 is 9. That's how we get this 9. But the whole thing is negative. Now we rewrote 1/5 plus negative 9/2 in place of the negative 4.5. Now we need common denominators. Common denominator for 5 and 2 is 10 because 10 is their least common multiple. So we make our new fractions with the denominator of 10. So 5 times 2 is 10, so we have to also multiply the numerator by 2. 5 times 2 is 10. 1 times 2 is 2. We're going to do the same over here. 2 times 5 is 10. So 9 times 5 is 45. But this whole thing is negative. Now we have our 2/10 plus negative 45/10. Now we can do our subtracting. We're going to subtract 45 minus 2 because it's an addition problem, but they're different signs. 45 minus 2 is 43. We keep the denominator, 43/10, and then we're going to use the sign of the bigger number. The bigger number was 45, so the answer is negative 43/10. We're going to convert that back into a mixed number by doing 43 divided by 10, which is 4 with 3 left over. 3 becomes our numerator in our fractional portion of our mixed number, 4 3/10. But the whole thing has to be negative because 4.5 is bigger than 1/5 and 4.5 is negative. All right. Whew, that was a lot. All right. Additive inverse is our last piece. Additive inverse is the same as opposites. If somebody asks you for the additive inverse of a number, they're actually asking you for the opposite. It's the same thing. So basically what additive inverse means is when you add opposites, you get 0. Okay, anytime you add opposites, you get 0. So basically negative 2.5 plus positive 2.5 is 0. All right, that is the end of the notes. I would like to remind you that you have some learn and do choices, you have some IXL, you have an HMH, and you have some practice here. I want to do in this video, I want to do this problem right here. Okay, I want to do -3 plus -1.5 plus positive 2.5 to remind you how to do this. We have 2 negative numbers added together, and then we have a positive number. So how in the world do I do that? All right, here's what I'm going to do. And I'm just going to scoot this up a little bit. Remember, same signs add and keep. And with addition, you can add whatever numbers you want together first. You can move numbers around with addition. So these are all addition, 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 right? When you can add numbers in any order you want. As long as it's all addition, you can move them around. That's called the commutative property of addition. Okay, so I'm gonna do these two first because they have the same sign. So I can just add and keep. So -3.00, and I can add as many zeros as I want after the decimal point. It doesn't matter. It's still 3. It's still -3. Plus, right? I'm gonna add -1.35. Okay, so I don't need that 0. 5 plus 0 is 5. 3 plus 0 is 3. 3 plus 1 is 4. Keep the same sign. Same signs, add and keep. Okay, now I added those two together and I got -4.35. So now I have -4.35 plus 2.5, right? Well, that's different signs. That's a negative, that's a positive. So now I need to subtract. So I am going to rewrite this with the 4.35 first because it's the bigger number, and the 2.5 down below, but I'm going to subtract them because different signs, even though it's an addition problem, same signs add and keep, different signs subtract. So now these are 2 place values. I can add zeros after the decimal. It doesn't matter. As long as I add them to the end, it doesn't change the number really. 5 minus 0 is 5. 3, you can't take 5 away from 3, right? You can't do 3 minus 5. So I'm going to borrow from this, make it a 3, and make this 13. 13 minus 5 is 8. Bring down my decimal. 3 minus 2 is 1. So the answer is 1.85, but I need to keep the sign of the bigger number. The bigger number was 4.35, so the answer is negative. Negative 1.85 is the final answer. Okay, so right here for number 12, the answer is negative 1.85. Now, this assignment right here, this is going to require scratch paper. Okay, notice how much work I just did on the scratch paper. I did the first step here, then I wrote the next problem, and then I did the problem. This part, really the whole assignment, all the assignments, even the IXL, you're going to need scratch paper. Okay, so good luck on your practice problems. I can help you if you need, and that is the notes and a little bit of practice help on 3.2.